Hello and welcome. In this class, we are going to be discussing about oxidizing and reducing agents. Yesterday, we talked about the definitions of oxidation and reduction reaction, also known as redox reactions. And while I was explaining to you the different way we can define oxidation and reduction, I also talked a little bit about what I called oxidizing agents and reducing agents. And I remember telling you that oxidizing agents are agents of oxidation, while reducing agents are agents of reduction. If you want to use those lame definitive words. But today, we are going to be dwelling on this topic properly. Now, we'll begin with reducing agents. What are reducing agents? Reducing agents are species in a chemical reaction that bring about the process of reduction. That means when you have a reaction and one of the substances gets reduced, the agent that brings about that reduction, is referred to as your reducing agent. What about oxidizing agent? Oxidizing agents are species in a chemical reaction that bring about the process of oxidation. That means they are the agents that causes the oxidation of another substance. Now, what I'm going to do here is that I'm going to give you certain equations that express oxidation and reduction in terms of oxygen, hydrogen, and also increase in oxidation number or electron transfer. I want you to watch closely because in these equations, I'm going to be showing you where oxidation occurs and the substances that causes the oxidation, or where reduction occurs and the substances that causes that reduction. So let's have the first one. So you can see here that this is a reaction between iron 3 oxide and carbon monoxide. And you can see in this particular reaction that iron 3 oxide is reduced. And why is it reduced? Because you can see that it was having oxygen here, but by the time it moved to the product side, there was no longer any oxygen attached to it, just the iron atom. And what has happened? Reduction. Why? Because reduction is removal of oxygen. I know you remember that. What about this one? This one is being oxidized. Now you can observe that carbon 2 oxide already has oxygen here. But by the time it got to the product side, or we had our product after the chemical reaction, the number of oxygen has increased from what you have here to be 3 to become how many? 6. You can see that. And because there is an addition of oxygen, we can term that process to be what? Oxidation. I'm not going to be defining this in the subsequent equations I'm going to give to you. But how can we identify oxidizing agent and reducing agent in this particular reaction? Now, this one, like I've established, has been what? Reduced. Now, what substance caused the reduction of this particular iron 3 oxide? What was the substance or the species or the agent that caused the reduction of this one? I guess you can tell me that would have been carbon monoxide. Why is it like that? Because you can observe that carbon monoxide is having just 3 oxygen here. It will end up removing the oxygen you have here, thereby reducing iron 3 oxide to just the normal atom as you have it here of iron. So the substance that is responsible for removing oxygen from this one, that now made it to result to become just your iron, is your what? Your reducing agent. So this one is going to be a reducing agent. Iron 3 carbon 2 oxide is going to be what? Our reducing agent. Now, what about in this one? How can we identify the oxidizing agent? The oxidizing agent is the one that added oxygen to carbon 2 oxide and now ensure that carbon 2 oxide was oxidized to become carbon 4 oxide. And you can get that right. You can see here that iron 3 oxide having oxygen lost, or let me say, gave out that oxygen to carbon 2 oxide. And carbon 2 oxide now gave birth to what? Carbon 4 oxide. So you can see here that the one that brought about the process of oxidation that caused carbon 2 oxide to be oxidized is your oxidizing agent. Is your oxidizing agent. I'm sure you got that right. Now I'm going to use another example and we'll see. Now this is another example and we have two equations there, but I'm just going to pick one. And I'm going to pick the first one. Now in this first one, what do we have here? We have hydrogen chloride or hydrochloric acid, if you want to use that word, if you know the states of the substance. Now it is reacting with oxygen. And now we can define this process Now we have the other chemical equation, and like I said, I'm going to be using the first one. And here we can see that hydrochloric acid reacting with hydrogen gas to give us chlorine gas and water. Please observe the fact that hydrochloric acid is having hydrogen here, but at the end of the reaction, hydrogen has been removed to form chlorine gas. And the name of that process, since it is a removal of hydrogen, is oxidation. Now, if you want to determine the substance that is the oxidizing agent in that particular reaction, you just look at the one that is reacting with hydrochloric acid. And as you can see here, it is oxygen gas. So oxygen gas is the one responsible for removing the hydrogen from hydrochloric acid to become chlorine gas. Now, you can also see the same thing for oxygen gas. You can see here that oxygen gas is just on its own in this place, but at the end of the reaction you can observe here that hydrogen has been added to it, and the addition of hydrogen, like we said the other day, is reduction. Now, what was the substance that caused hydrogen to be added to it? It's very clear here, and you can see it is what? Hydrochloric acid. So hydrochloric acid is going to be the reducing agent, because it is the one that brought about the reduction of oxygen to water, while oxygen is going to be the oxidizing agent, because it is the substance or the species that removed hydrogen from chlorine, and hydrogen chloride gets reduced to become chlorine gas. Like I said, I'm not going to use this other example. I'm just going to show you one that involves electron transfer and increase in oxidation number. Now, watch this closely. Actually, in this reaction, you can see here they actually give us the complete chemical equation for the reaction, but here they are also giving to us, this is the complete chemical equation for the reaction, this one, but we're also giving here the ionic equation. And you remember yesterday when we were talking about oxidation being an increase in oxidation number. So what you simply do is that look at the respective substances here and try to look at the superscript. That what number do they have in front and above them. That means that copper 2 ion will have an oxidation number of +2, and that is the oxidation number of copper 2 ion. But watch closely at the end of the reaction. Copper 2 ion now gets reduced to become copper, and the reason why it is reduced is because copper here does not have any number in front and above it, and we can assume that one to be what? 0. So copper 2 ion here moves from here with an oxidation number of +2 to this place with an number of 0. That is a decrease, and that is reduction. Now, how can you know the reducing agent in this particular reaction? The substance that gained that electron, or that was there and experienced the reduction of copper 2 ion to just copper as an atom, is the reducing agent. So magnesium, as we have it here, will become a reducing agent, because it is the one that reduced copper 2 ion to copper as a free atom. Now, it's quite clear here, if magnesium is being oxidized as a result of increase in oxidation number from 0 to +2, increase in oxidation number is oxidation, then the substance that is responsible for that is going to be the substance that's reacting with it, which in this case is copper 2 ion. So copper 2 ion is going to be our oxidizing agent. I'm going to give you people like an exercise to do here, and it's simply for you to find out how you can change or determine an ionic equation like the one we have here from a chemical equation like this. So you can see this one is a chemical equation, and they changed it or wrote it in such a way that it looks like an equation with ions. Now, these are the definitions of oxidizing and reducing agent. There are a lot more chemical equations you can use to illustrate this, and as time goes on, we are going to be discussing them. Now, let's move on from here and talk about the difference between the two species, oxidizing agent and reducing agent. First of all, an oxidizing agent is a substance that can be oxidized by losing some of its electron, while an oxidizing agent is a substance that can be formed by that can be reduced by obtaining electrons. Now, an oxidizing agent is a substance whose oxidation number increased. For instance, I'm going to explain that now. For instance, let's take this example for the ionic equation. I just told you that copper here is the reducing agent. Beg your pardon, is the oxidizing agent. And the oxidation number decreases from +2 to 0. So the substance whose oxidation number is decreased is the oxidizing agent. The substance whose oxidation number is decreased is the oxidizing agent. Now, a reducing agent is a substance that acts as an electron donor, while an oxidizing agent is a substance that acts as an electron acceptor. And you are going to be talking about this, or more of this, in the topic in chemistry we call electrolysis. Yes, electrolysis. And the other examples we have there is that substances that are oxidized during a chemical reaction is your reducing agent, while substances that are reduced during a chemical reaction are your oxidizing agent. I want you to take note of the contrast. The one that is reduced is the oxidizing agent, while the one that is oxidized is the reducing agent. That's how it works. Now, the last contrast you have, the difference is that a reducing agent is a substance that causes the reduction of another reactant, that brings about the reduction of another reactant, while the oxidizing agent is a substance that brings about the oxidation of another reactant. Now, we're going to conclude with this common examples of oxidizing and reducing agent, and I'm going to quickly talk about that for you, and to tell you that all metals, all reactive metals as you have it here, are reducing agents. All reactive metals like sodium, potassium, and magnesium, they are all reducing agents. Is that clear? And that means that anywhere you find them in a chemical reaction, they are going to be oxidized. They are going to be oxidized by either removing oxygen from other substances to become oxidized themselves by gaining oxygen, or adding hydrogen. You can also have examples of reducing agents as hydrides of metals, as metals that have hydrogen bonded to them, like your sodium hydride. Then examples of common oxidizing agents are all non-metals. Think of any non-metal like chlorine gas, fluorine gas, oxygen gas. Then all strong acid. Please don't forget that all strong acids are oxidizing agents. Most especially your sulfuric acid, your nitric acid, and your hydrochloric acid. Then you have acidified KMnO4 and acidified potassium dichromate, heptazoline dichromate 7. Now, lastly, we are going to be talking about the chemical test for oxidizing and reducing agents. It's in the content below, and I want you to look through it because in the content below I have diagrams to show you how we can test for oxidizing agent. We can test for oxidizing agent by using iron 2 ions, and we can test for reducing agent by